Welcome to SAIMASTER ACADEMY. We are going to discuss differential equations, maths 2B, calculus last topic. In that maths, differential equations, already I gave you introduction, finding order and degree of a differential equations and formation of a differential equations. Now we are going to discuss the methods to solve the differential equations. The first method, basic method, very important method for all methods. This is the hard type method. So if you know this method perfectly, you can solve complete solution. Otherwise, you can solve 50%, 70% of the remaining methods. Okay. So that's why listen carefully this method, variables separable method. Variables separable method. So in that word only we have meaning. Variables ni separate cheyadame variable separable method. So how we can do variable separable method for a differential equation? See, for example, if you have integral x dy, we can apply integration. Integral x dx, we can apply integration. X dx integration will be x square by 2 plus c, we know this. And integral y dy, we can apply same formula, x power n formula, it will become y square by 2 plus c. In this way, for which variable you are doing integration, with respect to that you have to apply integration. Same like differentiation. ఇక్కడ y ఉండి ఇక్కడ x ఉంది అనుకోండి రాదు, ఇక్కడ x ఉండి y ఉంది అనుకోండి రాదు. So with respect to what you are doing, that type of variable you require to apply integration. This method use is if you have like x dy, we can't do integration x dy. We need for x dx, but you what you have x dy and y dx. If you have an equation in this method like x dy, y dx, some sin x dy, cos x dy, sin inverse x dy, or cos y dx, like that, if you have irrespective variables with irrespective derivations, then you can apply this variable separable method. I will show you how we can apply this method and how we can solve the questions, and this is very important, I told you. See, if you have a function like f of x dy, f of x function in terms of x, plus or minus g of y dx, see function in terms of y. So f of x dy plus g of x dy equal to 0 or some constant whatever it is. If you have this type of differential equation, we can apply variable separable method to solve that differential equations. How we can solve? Just simply write f of x dy equal to minus g of y dx. I am taking right side at this column. And then always we know what? Integration something into dx, sin x dx, cos x dx, e power x dx, whatever it is, this dx always in numerator only. We can't write this sin x by dx. We have no this type of integration. Always dx or dy should be numerator. So here we have dx and dy, na? Both we have dy only, dx only. So these two should be always in numerator only. We can't change that. So what I am doing, I am taking this x function right side for dx, y function left side for dy. Then you will get what? This will be the denominator 1 by g of y, whatever it is a function in terms of y, into dy. And this is 1 by f of x into dx. This is minus. Now you can apply integration. You will get what? Integral y function dy, integral x function dx. You can get easily solution. Whatever it is your function, you can apply integration. You will get the solution. So this is a method, and very important method, basic method for all methods. This is a climax method. Okay. So now I will give you one example. There I wrote some questions, 6 questions. You have nearly 30-40 questions in your textbook. I am giving some questions. The first one, if you observe the first one, what is the first question? Solve root over 1 plus x square into dx plus root over 1 plus y square into dy equal to 0. This is very simple question. Just take right side or keep like this and apply integration. You will get the solution. Integral x dx, integral y dy. So function in terms of x dx, function in terms of y dy. What is integral root over 1 plus x square dx? Direct formula a square plus x square formula. Here also a square plus x square formula. If you apply, you will get the solution. And you know the formula for integral root over a square plus x square, that is what a square plus x square dx is equal to x by 2 root over a square plus x square. For a square plus x square and a square minus x square, you have only plus. Only for x square minus a square, you have minus a square by 2. For a square plus x square, sin h inverse x. Sin h inverse x plus c. When you apply integration, this will be a constant. Okay, now here what is a value? 1. Just applying the formula x by 2, that is same only x by 2. I'm writing that implies I'm writing the solution of this. X by 2 root over a square plus x square, that is root over 1 plus x square plus a square by 2, which is nothing but 1 only. 1 square 1, 1 by 2 sin h inverse, or in the formula x by a. So x by a is 1 only na, plus for this one I am writing now a square, again 1 square only, but in place of x just you have y. Just write here x by 2, y by 2. Since you have in place of x, y, so x by 2, which is y by 2, root over a square plus x square, 1 plus y square, plus a square by 2, which is 1 by 2, sin h inverse x by a, which is 1 by a, which is 1, sorry, y by 1, a is 1, which is equal to constant. So this is the solution. Here luckily we have the same variable dx, and for y dy. Now go to second question. So this is the second question. So what is that? See, second question, x y square, we have both x y. Okay, if you have this type of functions including x and y, go to variable separable method. X y square plus x into dx. See, if you apply dx for x, okay, for this, yeah, you have x and y both, na, so we can't do integration directly. Okay, continuation what given, plus yx square plus y into dy equal to 0. This is the given question. Here if you apply like this directly integration, you can't solve. Integral xy square dx, not possible. Integral yx square dy, not possible. Then how we can solve? By using variable separable method. So how we can apply variable separable method? We have to separate the variables. X terms ni dx వైపు తీసుకెళ్ళాలి, y terms ni dy వైపు తీసుకెళ్ళి ఇంటిగ్రేషన్ చేయాలి. That is only variable separable method. So first of all, what I am doing, I am taking this term totally that side. Yx square plus y into dy. I am writing this same as it is. I am taking this one that side, that is nothing but minus of xy square plus x into dx. So I think no doubt. So here dy, we need only y terms, not x square. Here dx, we need only x term, not y terms. What I am doing here, I am taking from these two y common. Taking y common, what is here? X square plus 1. So x square and taking y common 1 into dy, which is equal to minus, I am taking x common. Y square plus 1 into dx. Here this is dy, only y exists, but this one not exist. This is x term. For this you need dx. Where is dx? Here you have dx. So take that side, and y term take this side. Then what you will get? Y by 1 plus y square into dy, which is equal to minus x by 1 plus x square into dx. Now if you observe, y term undi, dy undi, x term undi, dx undi, direct integration చేసేసుకోవచ్చు. So integrating on both sides, integral y by 1 plus y square into dy is equal to minus integral x by 1 plus x square into dx. If you observe, this is by using substitution method we can get the solution. Y square derivation y only. So you can take, this is t, but you will get here 2y. Since y square derivation 2y. Here also x square derivation 2x. If you have here 2y, we can write directly the formula f dash x by f of x. But there is no 2, na? That's why both sides you can multiply with 2. I'm writing with blue color. Multiplying 2, here also 2. If you cancel 2, you will get the same equation. Now this is in the form of formula. I'm writing formula integral f dash of x by f of x dx, which is equal to log mod f of x plus c. So here f dash x by f of x, the derivation of 1 plus y square clearly 2y. The derivation of 1 plus x square is clearly 2x, which is in the form of f dash x by f of x, f dash x by f of x, which is log mod f of x. So which is nothing but log mod f of x, f dash by f, this only f always. So 1 plus y square is equal to minus log mod 1 plus x square, which is equal plus c na. So I am writing log c instead of plus c. Log c square c cube 1 by c, whatever it is, everything constant, ఏదైనా రాసుకోవచ్చు. మన క్వశ్చన్ కి రిలేటెడ్ గా ఏది అవసరం ఉంటే అది రాసుకోవచ్చు. I'm taking this negative term this side, then you will get what? Positive. So log of 1 plus y square plus log of 1 plus x square is equal to log c. Again logarithm formula. What is the formula? Log a plus log b is log a into b. So we can write log a into b is log of a 1 plus y square into b 1 plus x square is equal to log c. So both side log will be eliminated. Final answer you will get 1 plus y square into 1 plus x square equal to c. So that is 1 plus y square into 1 plus x square is equal to c. So this is the solution, and this is variable separable method. How we are using for all questions, we can use the same process of third one, fourth one, fifth one, sixth one. So we have to apply the same process, variable separable method, you will get the solution.